Hello dear students, listening to the difficulties expressed by class 10 students on the lesson carbon and its compounds, today I have taken up this lesson for making the video. Let us try to analyze the lesson in detail so that any doubt can be eliminated so easily. You need to understand the basic concepts which are related to these carbon compounds, then the lesson will be so easiest one. Now, first we need to understand why do we need to study the carbon compounds, carbon and its compounds, why do we need to learn. The reason is we are surrounded by many substances which are made up of carbon. Just let us take the example. If you take whatever the food we are consuming, that is just made up of carbon. If you take medicines and drugs, they are also products of carbon. If you take fuels, kerosene, petrol, diesel, wax, coal, these are also just products of carbon. If you take fabrics, they are also made up of carbon. So, since we are surrounded by carbon, we need to learn in detail the carbon and its compounds. Now, let us take how the bonds are formed in carbon compounds, that is bonding in carbon first. In inorganic chemistry, you already studied what are ionic bonds. Ionic bonds are nothing but it is complete transfer. If the bond is formed by complete transfer of one electron from one atom to the other atom, that bond formed will be ionic bond that you already studied. Now, in carbon compounds, the bond formed will be covalent bond. Then you need to learn what is the reason for this carbon compound to make covalent bond. Why it is forming covalent bond? The reason is, first we need to understand the electronic configuration of carbon. That is, carbon is 6 atomic number. If you write the electronic configuration, 1s2, 2s2, 2p2, right? Now, this is first energy level. There are 2 electrons, and in the second energy level, there are 4 electrons. Not only carbon, you take any other element. If it is reacting with some other element, there must be a reason. What is that reason? It is nothing but any element it wants to completely fill its outermost orbit. Means it needs to have a completely filled outermost energy level. Here, this is inner energy level, this is outermost energy level we can consider. Here, if you take the capacity of each energy level, first energy level, that is 2 electrons, and in the second energy level there will be 8 electrons. If it is to be completely full, then there must be 8 electrons. In any atom, if you take the outermost orbit, if it is having completely filled shell, that wants to attain 8 electrons in its outermost orbit. Once if it has 8 electrons in its outermost orbit, then it is called noble gas configuration, or we can call this as octet structure. In any element, this is only main reason. If you take carbon, this is the nucleus, this is first energy level, there are 2 electrons. And if you take the second energy level, there must also be 8 electrons, because this shell has to be completely full, but it has 1s2, it is, this is 2s2, 2p2, means there are only 4 electrons in the outermost orbit. Now, in order to have completely filled outermost orbit, it has to lose all the 4 electrons. If it loses 4 electrons, number of protons is 6 there. Electrons is only 2 will remain. And to remove these 4 electrons, very much high level energy is required. It is not so easy to remove all the 4 electrons from its outermost orbit. Then, if it wants to have another 4 extra electrons in this, then completely filled orbit it will get, of course. Okay, 8 electrons it can get. But with this only 6 protons, here 2, here 8, total 10 electrons will be there. Those 10 electrons it cannot balance with only 6 protons. Only 6 will be there protons. It becomes unstable atom. Because of that, it can neither gain 4 electrons nor lose 4 electrons. If it wants to lose, high energy is required to remove that. It is difficult to remove 4 electrons. And if you want to give extra 4 electrons, negative charge becomes more and positive charge will be less. Only 6 protons. It cannot balance all the 4 electrons. It cannot hold those electrons. Because of that, it goes for one more type of bonding, that is called covalent bonding. What is covalent bonding then? It is nothing but just sharing of electrons. If the bond is formed between two atoms by mutual sharing of electrons, then that type of bond is called covalent bond. For example, let us take some few simple elements. In that, what type of bond, that covalent bond, how it is formed, let us try to understand. If you take hydrogen H2, how it is formed bond? If you take hydrogen, one electron is there in this. One electron is there in hydrogen, and it does not have completely filled shell, because the first energy level it must have two electrons, right? But it has only one electron, hydrogen. So what it does, one more hydrogen, it will also come to join with this hydrogen. Now this pair of electrons is shared by this hydrogen. Now it is 1s2, means completely filled outermost orbit it became now, and the same pair is shared by this hydrogen also. Means now both the hydrogens, they are having completely filled outermost orbit. Now they are stable, we can say. So this is how this bond is formed in hydrogen, that is covalent bond, because sharing of electrons is there. These cross marks, they show electrons. Now coming to, let us take one more atom, that is oxygen. If you take oxygen, it is 8. 1s2, 2s2, 2p4. Now 2s2, 2p4. Here, how many electrons are required to make this completely filled shell? 2 plus 4, 6. This capacity is 8. Means 2 more extra electrons are required for this, in order to make that completely filled orbit, that is octet structure. If it wants to attain the noble gas configuration or octet structure, it needs to get extra 2 electrons. So what it does here, if you write one oxygen atom, here electrons if you show, only this outermost orbit electrons we are showing, that is 2 plus 4, 6 electrons. If you show 6 electrons like this, we need to show. Now here 2 electrons it needs to have, right? Then you take one more oxygen. This also has 6 electrons in its outermost orbit. Here 2, here 2. Now you see 6. This pair, it is shared by this oxygen atom, and this pair is shared by this oxygen atom. Now you can see here. Now 2, 4, 6, 8. This got what octet structure, noble gas configuration, it got this oxygen. And if you come to this oxygen atom, this is also sharing this pair with that. Okay. Now here each atom, it is sharing a pair of electrons. So the bond formed will be double bond between oxygen. In case of hydrogen, only one electron is shared, single bond is formed, H, right? Between the oxygen atoms, double bond, because here each atom is sharing one pair of electrons. Okay, so this is how the bond formation, that is covalent bond formation, takes place in case of oxygen. Now let us try to understand how it is formed, that bond formation in nitrogen. If you take nitrogen, what is the electronic configuration of nitrogen? It is 7, 1s2, 2s2, 2p3. Nitrogen 7. Now in the outermost orbit, you see there are 2 plus 3, 5 electrons, right? First 2, next 5 is there. Here 3 electrons it needs to get here extra, nitrogen. So if you write nitrogen electronic configuration, if you write, only outermost orbit electrons we need to show there. So how do we show? Here 2 plus 3, 2 plus 3, these 3 electrons we are sharing, showing one side, here one pair one side, and one more nitrogen if you take, here 3 electrons and here 2 electrons. Why I am taking like this? Because here if I just keep 3 outside, another 3 are required. So total 6 plus 2 8 it becomes. Because of that 3 one side, 2 one side I am making. Here also in this case. Now you see this pair of electron is shared by this nitrogen, and this pair of electrons it is shared by this nitrogen. Now you see both are having completely filled orbit, that is octet structure they attained already. Because here 6 plus 2 8 for this, 6 plus 2 for this also 8. Now the bond formed between the nitrogen atoms will be triple bond, because 3 pairs of electrons it is shared. So because of that the bond formed will be triple bond between nitrogen atoms. This is examples of some simple simple compounds we can say, that is elements which are combining themselves to make the covalent bond. This is over. Now let us come to know about uh, bonding in carbon. Okay. If you study in simple compounds of carbon, the first element if you take, that is methane. Okay, this is just methane. Next, methane, ethane, propane, butane, so many will come there, that we will study in the next section. Now let us study the versatile nature of carbon. Means the carbon compounds, number of carbon compounds, it exceeds millions. Chemists, what they have formulated the compounds, it exceeds the number in millions. That is, if you consider the bonds formed by other elements, these compounds it outnumbers the compound formed by all the other elements in the periodic table. In millions we can find the carbon compounds. Then there must be a special property of the carbon, that is called versatile nature of carbon. That is nothing but, first is catenation. What is catenation then? Catenation. Carbon has the unique ability to form the bond with the other carbon atoms. One carbon atom, it can form the bond with other carbon atoms. This property of the carbon is called catenation, right? With the help of this property of catenation, it forms long chains of carbon or branch chains of carbon. Branch chains also it will be forming, or the carbon atoms which are arranged in rings we can find. So because of this special property of catenation, it is making millions of compounds. And not only this, the carbon compounds which are linked by single bond, they are called what? Saturated what carbon compounds. These are saturated carbon compounds. And if the carbon compounds, if they are having double or triple bond, if it is having double bond or it may be having triple bond between the carbon atoms, then these types of carbon atoms, they carbon compounds, they are called unsaturated hydrocarbons. These are unsaturated hydrocarbons. Unsaturated carbon compounds. Okay. Now, next comes the property of this catenation cannot be exhibited by any other element as to the extent which can be seen in case of carbon. Means it can be seen in large extent in case of only carbons. Okay. There it is what for making the bonds with other atoms or with the carbon atoms. That property of catenation will not be exhibited by other elements. Even if you take some of the elements are there, that is, if you take silicon, it can make the bonds with up to 7 to 8 atoms, but those bonds will not be stable. They are highly reactive. But the bonds formed by these carbon atoms, that will be stable. Since the valency of the carbon atom is 4, valency of the carbon atom is 4. What is valency? You know that already. That is the tendency of an atom either to lose or gain electrons. Why? In order to attain outermost orbit to be filled there. Means completely filled outermost orbit. In order to get that, either it is giving or gaining the electrons. This tendency is called what? Valency, right? Valency of the atom. Here valency of the carbon is 4. Means what? It can either, it wants to give 4 electrons or it wants to gain 4 electrons. Since, as we already discussed in the previous section, since it is difficult for completely transferring 4 electrons or gaining 4 electrons, it is going for sharing 4 electrons with other atoms in order to get that completely filled outermost orbit. That is in order to attain noble gas configuration, octet structure. So here, since the valency of the carbon is 4, this can make the bond with other 4 carbon atoms. Okay, it can make the bond with other 4 carbon atoms, or it can make the bond with other atoms which are monovalent. Finally, the 4 bonds have to be formed with 1 carbon atom. That has to be satisfied. So because of that, it is sharing the electrons with other carbon atoms it may be, or the other elements it may be. Atoms of other elements it may be. Now, the bonds formed by the carbon with other atoms. That bonds formed by the carbon with other atoms means it can make the bonds with sulfur, nitrogen, oxygen, chlorine, with many other sulfur, okay, many other elements it can make the bond with them, okay, right. It can form the bond with them. These bonds formed with other elements, they are highly stable, they are very strong. Fine. The main important reason for this is, this can be asked in the examination in the form of reason. Why are the bonds formed with other elements by the carbon are strong and stable? The reason is the small size of the carbon. What is small size? It is nothing but, if this is the nucleus, this is first energy level, second energy level. Okay. Now here the radius, if you take radius of the atom, this is smaller because just in the second energy level itself it is finished. The bigger atoms, they will not be forming the bonds, strong bonds with other atoms. They will be weak because as the distance of these electrons increases from the nucleus, that bond formed by those atoms will be weak. If it is close to the nucleus, this outermost orbit, if it is close to the nucleus, then the bond formed by that atom will be strong. Because of that, the bonds formed by carbon with other atoms will be strong and stable. Okay. This is just a versatile nature of carbon, we can say. Because of this, it can make the bonds with other carbon atoms or other atoms of monovalent, we can say that. Now let us try to know here what are the saturated unsaturated carbon compounds. Saturated carbon compounds means, we already just now we discussed, it is nothing but if the carbon atoms are linked by single bond, that is called saturated carbon compounds, we can say. If there is double or triple bond between the carbon atoms, then such carbon compounds, they are called what? Unsaturated carbon compounds, we can say, right? Now let us try to write the electron draw structure for unsaturated carbon compounds. Unsaturated carbon compound means there must be double or triple bond, right? Now let us take a compound that is ethene. Ethene. How it comes ethene, ethane, ethine, that I am going to take in the next section. Now if you take ethene, eth means there must be 2 carbon atoms. It is eth. Here bond is ene means a double bond will be there. It will be double bond. Then this electron structure we need to show here. How it is coming? That is 1s2, 2s2, 2p2. Okay. In the outermost there are 4 electrons. So carbon atom wants to get 4 extra electrons. That is why valency of carbon is 4, right? But it cannot get it completely, as we already discussed now, because it cannot hold it. But instead of that, it is going for sharing to make that covalent bond, right? Now, how it is sharing then with other carbon atom? If you write one carbon atom, 4 electrons, we can show like this. Here too, 4 electrons for one. Another carbon, for this also 4 electrons, I can show like this, right? You can show here. Now, this pair of electrons of this carbon atom will be shared by this carbon atom. So how many electrons it got now? Total 4 plus 2, 6, right? But it wants extra 2 electrons. Then how it can be gained? Here one hydrogen comes and gives 1 electron. This is making one single bond with carbon. And here also one more hydrogen comes and it gives 1 electron. And this is also forming one single bond with the carbon, right? Next, in this case also, this pair of electron is shared by this carbon atom. Now you can see total 4 plus 2, 6 electrons. Here one hydrogen, it is giving 1 electron to this carbon atom forming single bond. And here one more hydrogen, it is giving 1 electron and forming single bond. Now if you count the number of electrons in the outermost orbit of each carbon atom, there will be 8 electrons. Here these are 4, 2, 6 plus 2, 8 for this carbon. If you take this carbon, total 4, 6, 8 means both the carbon atoms, they are having completely filled outermost orbit. Not only that, even hydrogen is also having 1s2 capacity, that is both electrons it is filled already. By sharing, it has got 1s2 electronic configuration now, completely filled outermost orbit. So these electron pairs, since there are 2 electron pairs, there will be double bond between the carbon atom, and here one hydrogen and here one hydrogen. This is structural formula of ethene, we can say. Just it is ethene. And ethene, methane, propane, butane, how these are coming, that we are going to learn now, right? Before going ahead with the next compounds, let us try to understand those first. Now let us try to understand how to write the structural formula for the carbon compounds and how to name them. In order to name and write that structural formula, first we need to know few things there related to these compounds. If there are number of carbon atoms, if it is 1, 2, 3, what are the names that we are writing along with them, we need to know. First one, if it is 1, then it is called just meth. If it is 2, that is called eth. 3, that is pro. 4, but. 5, pent. 6, hex. If 7 carbon atoms, it is called hept. If 8 are there, that is called oct. If 9, non. And if it is 10, we take it as dec. You must remember all these things first. Okay? Now, if you want to write methane, how to write that methane? Meth means a single carbon atom. Okay, only one carbon atom, because meth means 1. So 1 carbon atom you need to write. Now, valency of carbon atom is 4. In order to satisfy 4 valency, you need to show 4 bonds with carbon. Those 4 bonds should be formed by hydrogen. Means what? For 1 carbon to satisfy its 4 valency, you need to give 4 hydrogen atoms. Just you write 4 hydrogen atoms. Then there will be 4 single bonds. 1, 2, 3, 4. Now valency is satisfied. Carbons. Now we can name this as just methane. Why methane? Since carbon atom is 1, it is meth. Since each hydrogen is making single bond with that carbon, that is ane. methane, right? This is how we are getting. If you want to write ethane, ethane means there must be two carbon atoms, right? And there must be single bond. If there is single bond between the carbon atoms, then we are applying En. Okay. Now here one bond is already, one carbon is making one bond with other carbon. Then how many extra three means extra three bonds it needs to make? What is that? Here one, here one, here one, three bonds. In these three bonds, if no other atoms are there, just you put a hydrogen here. Substitute by hydrogen. Here also three hydrogen. Now you see 1, 2, 3, 4, 5, 6. Then if you write the formula, this will be C2H6. C2H6 formula. Structure is this. Then how to name this? Here there are two carbon atoms. So that is why it is called eth. According to this, it is eth. Since all the hydrogen and between the carbon atoms, since there is only single bond, that is called ane, ethane. Finished. Next, if you want to come to write any other higher carbon compounds will take. For example, hexane will take. Hexane, if you take, hexane means there must be 6 carbon atoms as we have written here already, right? So you just write 6 carbon atoms. 1, 2, 3, 4, 5, 6. Okay, 6. Now, for each carbon atom, there must be 4 bonds. Like that, you need to put a hydrogen. Just substitute hydrogen. For first carbon, you can substitute 3 hydrogen. Now you see total how many bonds it is forming? 1, 2, 3, 4 bonds. Finished. It is over. Next come to second carbon. Second carbon, here already it is having 2 bonds. How many extra hydrogen you can give to make it 4? Extra 2. Here one, right? Now for this also same. For this also same. Now in this last one 3, because here one extra if it is given, then it becomes 4. For this carbon atoms 1, 2, 3, 4. For any carbon atom you check, there will be 4 bonds. So this is what a hexane. Since there are 6 carbon atoms, it is hexa. Since a single bond between the carbon atoms, it is called a ane. Total hexane it is. Okay. This is how up to decane you can write any carbon compound with a single bond. These carbon compounds having single bond between that carbon atoms, they are called what? Saturated hydrocarbons or saturated carbon compounds we can say. Okay. Saturated carbon compounds these are. Now let us take uh, here, if double bond or triple bond if it is there, then how to name these carbon compounds, that we need to learn here. Now if you are asked to write ethene, propene, butene, in such cases, how to write the structural formula? Here if you are asked to write ethene, ethene means how many carbon atoms? There, 2. If 2 is there, it is called eth, right? So there must be 2 carbon atoms. Ethene means between the carbon atoms there must be double bond. If there is double bond, that is named as ene. If it is single bond, then it is ane. Ethane is single bond, ethene is double bond. Since there are already 2 bonds here, here one, hydrogen you can substitute. Now you can count, there are 4 bonds again for each carbon atom. 1, 2, 3, 4, 1, 2, 3, 4, finished. So this is structure of ethene. Formula if you want to write C2, this is H4. There are H4 hydrogen atoms. Okay. Next, if you want to take this one for a higher one, propene if you want to take, propene, 3 carbon atoms. Prop means 3, 1, double bond has to be there, 2, next one 3. Now I am not writing here also double bond. There may be only one double bond or more than one double bond. If at least one double bond is there, that has to be substituted by ene. not En, Ene. That is propene we are saying. Let us take this as single bond like this. Means a double bond having only one side double bond. Now how many hydrogen you can substitute here? 4. Okay, here 2, here 2. 4, it is satisfied, valency. Here 3 is there, here 1 bond. We can give 1 hydrogen to this one. So we can write it like this. CH, 1 hydrogen we can write for this. For this, again, how many we can give hydrogen? 3 we can give here. 1, 2, 3, 4. Here 1, 2, this bond is 3, 1 hydrogen, that is 4. Total 4. If you want, you can show it here also. See now. 1, 2, 3, 4. 1, 2, 3, 4. Means each carbon atom is having 4 single bonds. Okay. And here it is double bond. If there is at least one double bond, then the suffix has to be taken as a "ene" with the carbon atoms, number of carbons. It is pro. Since one double bond is there, "ene" we need to write. So this is called propene. Right? If you take here next butene, hexene, heptene, whichever you can take. Now let us try to take same one for this one. Propine, butane. In case if it is ethine, like that we'll see. Okay. Now, if you are asked to write propine, how to write the structural formula for this and molecular formula? If you want to take this, prop means 3 carbon atoms. 3 carbon atoms. Propine means at least one triple bond has to be there. One triple bond I'll show here. Right? Next here single bond. For this carbon you cannot give any hydrogen now because here 3 bonds, here 1, total 4 bonds, it is satisfied already. For this carbon atom 3 bonds are there, you can give only 1 hydrogen for this. And for this carbon atom you can give only 1 bond is there, you can give 3 hydrogen for this. H, H, H. Now if you write the formula, this will be C2 propine, C3 H. How many are there? 1, 2, 3, 4. H4. C3 H4. If you write next member of this carbon compost, if you write hexane, pentane, whichever, here pentyne we will write. Pentyne. If you want to write pentyne, you just write 5 carbon atoms. Here 1 triple bond, here single bond, single bond, single, here also single bond. Now you can give here 1 hydrogen for this. 1, 2, 3, 4. Finished. 1, 2, 3. Here 1, 4. For this carbon you cannot give any hydrogen. For this 2 are there already. Here 1 hydrogen you can substitute. And for this also here 1 you can substitute. Here 1 and here 1. Total how many hydrogen now? 1, 2, 3, 4, 5, 6, 7, 8. If you write this will be carbon atoms 5. C5H8. Okay. Now we can get one general rule for this. This you can write this as CN H2N minus 2. You can write here general formula. Now we can write the same butane you can write in 2 forms. This is straight chain and one more branch chain also we can write C and here one more C. You can take it like this also, right? This is branch chain we can see. Here this is long chain. In order to satisfy the hydrogen single bond, here 3 hydrogen you can give. Here for these two, for this two, and for this again 3 hydrogen, right? Here if you want to write for this again hydrogens, here single bond you can give 3 hydrogen for this also 3 hydrogen, 1 2 3 4, 1 2 3 4 bonds, and here for this 1 hydrogen. Now you can see here, and for this also 3 hydrogen. Now 1 2 3 4, for this also 4 bonds, 1 2 3 4, for this also 1 2 3 4, and here also 1 2 3 4. Each carbon atom is forming 4 bonds. Okay. So this is structure of butane, we can say. This butane formula, if you write molecular formula, what will be that? C4, 4 carbon atoms, C4. Hydrogen, how many are there? Here 1 2 3 4, 4 to the 8, 9 10, it is 10, C4H10. Here also if you count C4, 1 2 3 4 carbon atoms, here 3 hydrogen, 6 plus 3 9, 1 10, H10. Here molecular formula is same, but structural formula different here. Then such type of compounds, they are called what? Structural isomers, because only their structure is different, but their molecular formula is same. If any carbon compound, if they are having identical molecular formula but different structural formula, then they are called structural isomers. Okay. If you want to write here cyclohexane, hexane means 6 carbon atoms, that is why I wrote 6. Cyclo means it has to be in the form of ring. Here just number of hydrogens have to be given in order to satisfy the valency of carbon, that is 4. Here for each carbon atom, here 2 bonds are there already. For this you can use 2 hydrogens. Here also for this also 2. Here 2. Here 2 hydrogen. For each carbon atom you can give 2 hydrogen atoms. This is called cyclohexane. Okay, we can call this as cyclohexane. Next, one more comes, that is benzene. What is the structure of benzene? Here carbon, here benzene means in it is coming, there must be double bond. That double bond we need to show here. If you show here double bond, here there will be single bond. Here double bond, single, double bond, single bond. Now for this carbon, 2 plus 1, 3 bonds are there. 1 extra hydrogen it is requiring. We are giving 1 hydrogen for each carbon. Each carbon is getting 1 hydrogen, so that valency is satisfied here. So this is what benzene we can say. This is just benzene. Structure of benzene, if it is asked, 6 carbon atoms you write, in between alternate double bond and single bonds you have to write. Next, to satisfy that 4 valency, 1 hydrogen is necessary for each carbon atom. If you write that, that will be the structure of benzene. Okay. Now if you are asked to write any type of compound, it may be, you just remember either nomenclature comes next section, we are discussing that. If you are asked to write any compound, structural formula or molecular formula, if they are asking, just you look at the name. If they are saying let us take anything here, propine, we already discussed let us take one more heptine. If I take heptine, how to take this? Carbon atoms, they have to be 7. Okay. Ine, heptine. What will be the formula for single bond, double bond, triple bond? There are particular what formula are there for that? For single bond, it is CnH2n plus 2, and double bond CnH2n, and triple bond CnH2n minus 2. We are not deriving this. If you write that double bond structural formula and if you count the number of hydrogen atoms in that, you will get these only. Okay, general form if you write, you will get this formula. Now, if you want heptine, heptine means what? Here this is single, double, triple bond. Okay, ine if it comes a triple bond, you have to use this formula CnH2n minus 2. Then C7, H how to write? Here in place of n you write 7, means what? 2, 7 minus 2. This will be C7, H, 7 to the 14 minus 2, 12. This is 12. This is the molecular formula of that given compound, that is heptine. This heptine structure, if you want to write, what to do? You need to show one triple bond, and for other carbon atoms, just you have to give hydrogen atoms to satisfy that remaining bonds there. Now, let us try to understand what are functional groups. Group of atoms which give special properties to the carbon compounds, they are called functional groups. Right? Here, for example, if you take CH4, it is methane. If you write this formula, this is methane. Instead of one hydrogen atom, if any other group of atoms such as OH, it is replacing one hydrogen and it is coming here in this place, then this heteroatom which is coming in place of hydrogen, this is called heteroatom. This heteroatom, if it is group of atoms, it may be, or single atom it may be, means single elements, then this is called a functional group. This functional group is providing a special property to that compound. Now this is called what? A methanol. Means what? This is giving alcoholic property to that carbon compound here. Next, if you take ethanol, here this is ethane, right? This is ethane. In place of one hydrogen, if it is coming OH, this becomes ethanol. Okay, means just one group of atoms, what it is giving their special property to that compound, that is called functional groups. There are few functional groups which are introduced in the textbook. Which are the first one? Here, haloalkanes. Haloalkanes means here chlorine and bromine. These halogens, these are called halogens. If these are coming, they are called haloalkanes. For example, here this is methane. Okay, for this methane, in place of one hydrogen, if chlorine is coming, this is called a chloromethane. Right? If in place of chlorine, if bromine is coming, then it is called a bromomethane. This is functional group. Then how to write? Here for haloalkanes, we are taking these as prefix. Prefix means what? Here, this is methane. If you are writing, name is methane, right? What is there in place of one hydrogen? Bromine is there. This bromine, you write it as a bromomethane. Bromomethane, right? This is just a bromomethane. We are writing this as bromo is a prefix. Methane as it is we are writing. But in some other functional groups, such as aldehydes, alcohols, ketones, carboxylic acids, if they are coming, they will be suffixes. Then coming to here, aldehydes, if you take aldehydes, Aldehydes means it is one CHO group. It is carbon, one hydrogen, one double bond, one here extra free bond will be there. This is attaching with other carbon compounds, and this entire entity, this is called what? Functional group. One CHO it is. If you write this in short, it will be like this. CHO. This is aldehyde. Next, coming to alcohol. Alcohol group will take here. Here OH. This is alcohol group. Okay, if it is attached in place of one hydrogen, then it becomes we are giving suffix for this as all. For this suffix we are giving it as all. For this al suffix we are adding it as al. For example, here ethane, carbon, hydrogen. This is now this is ethanol. This is ethanol. It is okay because two carbon atoms are there. Eth. This is what aldehyde group. So because of that we are giving that suffix as al. So ethane. First it is ethane. Since this functional group is there, we are adding it as a ethanol. That is ethanol. Right. Next, if it is ketone group, ketone means one carbon, double bond O, here like this, free ends will be there. Then this type of functional group is called ketone. If it is present with a carbon atom, for example, we will extend this like this. Here one carbon, here one carbon, we will make. Right? Here number of hydrogens you write to satisfy the valency. Now here 4 bonds are already over, you cannot write anything. Here 3 hydrogen. Total 3 here, 3 here, 6 hydrogen atoms. Now you, since this group, this functional group is called what? A ketone. If you name this 3 carbon atoms, that is pro. Okay. We are calling this as propane. In that propane, since this ketone group is there, here propane, right? Here, if any of these functional groups, if they are starting with the vowels, for example, ketone, ONE, okay, is and AL, aldehyde, alcohol, OL. These suffixes, if they are starting with vowels, then this E you have to replace by only this is direct suffix. For example, here ketone group is there. Because of that, propane replacing E, ONE for ketone it is. Ketone, it is ONE. You write in this place as ONE. Finished. Propanol. Now it is propanol. Right? If it is butane, butanol. What type of functional group is there? That suffix you need to add. Before adding that AN will be there. E, last E you have to remove. And you have to delete that E and just you have to add this direct suffix there. Then it will be complete name of that propanol. Next, if you want to take one more functional group is there, that is called a carboxylic group. Carboxylic acid group is a functional group. If it is carboxylic acid, then it will be just oic acid. Oic acid we write for this. Means carboxylic acid, how it will be there? It will be like this. CH3 COOH. In this COOH. Okay, this is what a functional group COOH. Okay, this is what a ethanoic acid. It is ethanoic acid. Why it is ethanoic acid? There are two carbon atoms, 1 2, so that is why ethane. In that, since COOH group is present, for this suffix we are giving this as a oic acid, so this becomes a ethanoic acid. Ethanoic acid. See, if a COOH group comes, oic acid you have to mention. After that, alkane. What are removing last E, right? So that is why this is ethanoic acid. And here propanol, ketone it is. If it is ketone, you need to write ONE. If it is aldehyde, you need to write AL. Aldehyde, AL. If it is alcohol, then you need to write it as OL. These will be the suffixes for this. Carboxylic acid, oic acid. Acid. This will be suffix will be oic acid. Right? You need to remember all this. And if it is chlorine or bromine, you are making it as prefix. If it is ethane, bromoethane. Chlorine is their functional group, then chloroethane, you can say. But if it is apart from those halogens, chlorine or bromine, apart from that, if these functional groups are coming, then you are adding these as suffixes. If it is propane, propanol it may be, propanol it may be, propanol it may be, or propanoic acid it may be. Okay, yes. Next, coming to functional groups, homologous series. Now let us try to understand what are homologous series. What is the meaning of homologous series? Now you take, for example, CH3OH. According to this alkane formula, if it is methane, it will be CnH2n plus 2. This is the formula, right? But one OH group it is replacing, that is why CH3 it is becoming. So next, C2H5OH. Next, C3H7OH. C4H9OH. How we are getting this? You see, if it is alkane, for example butane, if it was there, C4H2n plus 2, 2n plus 2, this would be C4H, 4 to the 8 plus 2, 2 is 10, H10 it would be there. But one alcoholic group, OH, is replacing one hydrogen, that is why this becomes 9. So C4H9. Here also similarly same, here also. Now each member, if you consider, just you find out the difference in the next higher member. What is that? Here one carbon is extra here in this. One carbon is extra. Here 3 hydrogen, here 5, means 2 hydrogen is extra. Right? And if you take the next higher member than this, what is extra here? 1 carbon extra in this and 2 hydrogen. Here 5, here 7. CH2. Right? Next, if you consider this one, again, how many extra? 1 carbon. Here 3, it is 4. 1 carbon extra. And here 7, it is 9. Here 2 hydrogen extra. Means in the next higher member, it is just differing by 1 CH2 group. Okay. Everywhere it is just having one extra CH2 group. Next higher member. Then these types of carbon atoms means same group of carbon atoms which are differing by one CH2 group. Each higher member, if it is differing by one CH2 group, then these types of carbon atoms, these types of carbon compounds, they are called what? Homologous series. For example, homologous series means what? Here each carbon compound is having here functional group alcohol. Means what? The property of alcoholic property of that compound, that remains same, but what changes here? Only as the members, that is number of carbon atoms and hydrogen increases, that is molecular mass of the compound increases every time, because every time one CH2 group is increasing there, so that is why molecular mass increases. If the molecular mass increases, there will be gradation, means there will be change in what boiling point or melting point of that particular carbon compound, that will also be rising. But if you consider the chemical properties, that remains the same. Means what you can say, if they are asking you uh, in the homologous series, what are the difference? What happens to the physical and chemical properties of that particular carbon compound in the homologous series? Only chemical properties will remain same, but physical properties they will be changing. They will be increasing because molecular mass as it increases, their physical properties such as melting point, boiling point, and all they too will go on increasing. This you can say this is just a homologous series. Next, coming to nomenclature. Nomenclature very much simple. If they have given any compound, very easily you can say what type of compound is that. If it is, just you find out whichever it may be. Uh, Let me write here one structure. Afterwards, we will name it. What type of compound is that? I will write like this. See, let me write here double bond one, single bond. Here OH. Uh, Here 1, 2, 3, 4. This is one more hydrogen I'll write here. Here two bonds are there. Here two hydrogen I'll write. One OH group is there. Means according to that rules, all the four bonds it is satisfied for each carbon atom here. Now we don't know what type of carbon compound we have written. Now we will name it. How? Just you count the number of carbon atoms here. 1, 2, 3. Just you write this as 3 carbon atoms means what? Probe. Yeah, first name it is probe. Now you have to go for bonds. Check the bonds. Whether it is double bond is there anywhere, single bond is there, or triple bond is there, you check. Now one side it is double bond. So probe, here this is double bond, propene. Okay, propene. And one alcoholic group is there. What this happens? Alcoholic group, it is OL, right? Here this propene, in this case you have to replace this last E. Why? Because this is starting with OL, that is O. In this place you write L, OL. This becomes propanol. Name of this compound is propanol. So far we are familiar with propanol. Now it is propanol, right? Now in the next, if you take one more uh, carbon atoms, we will write like this. Now what we will do is, this is under functional group we have studied. This is what? Ketone group, right? Now if you take here double bond, this functional group is a ketone. Now what we are doing, I'll just add one more carbon to this. Now what happens, you see here four bonds already satisfied. Here we cannot do anything. Here you write 3 hydrogen. Here this is ketone group. This side you write. You should not mix up with that. Now here 2 hydrogen. For this 3 hydrogen. Right? Total how many hydrogen are there? How many carbon atoms are there? Just we'll check it once. 1, 2, 3, 4 carbon atoms. So we can write this as but. Now here but. Here double bond or single bond, where if you go through that, everywhere it is single bond. There is no double bond. Then this will be butane, right? Butane. But functional group, it has to be suffix. What is that functional group? ONE. ONE it is. If ONE means this is starting with OL, so you have to replace this E with ONE directly. ONE means this becomes, or this became what? Butanol. 4 carbon atoms with single bond with functional group ketone group. That is why this is what? butanol. Just you can name it like that. If you take some others also, you can name in the similar way. Aldehyde group you can take. Otherwise, here one more will take. This is double bond. Here one hydrogen. Here what we will do is one hydrogen, one chlorine. If anything, if it is there like this, chlorine is replacing one hydrogen, then if there is only hydrogen, you would call this, how we would name this? Two carbon atoms, so ether double bond ethene we would say, right? Now since chlorine is there here, you have to name this as a chloroethane. This is chloro, you cannot say ethane, chloroethene. It is chloroethene because of what? Double bond. If it is single bond, chloroethane it would be, since there is double bond between the carbon atoms, that is chloroethene. Just looking at the number of carbon atoms, finding the bond and adding either prefix or it may be suffix. Except chlorine and bromine, all are suffix. If it is chlorine or bromine, then it will be prefix with that name. If you do this much, it will be over. This is coming under just nomenclature. And carboxylic acid group, if it is there, for example, I'll take one more here, CH3COOH. Okay, this if you write structural formula for this, C double bond O, here one OH, COOH it is, right? Now CH3, here 3 hydrogen you need to write, CH3 COOH. Now if you want to name this, how to name this? Two carbon atoms, so it is eth. Okay, single bond, so it will be ethane, right? Now what is the functional group? Functional group is a COOH group. If COOH group is there, its name here E has to be replaced by oic acid. Then this will be ethanoic acid. So this is how we are naming the carbon compounds. Now we shall study the chemical properties of carbon compounds. So far we have studied about alkanes, alkenes and alkynes and their general formula we studied, and how to write nomenclature, structural formula, molecular formula, electron dot structure, everything we have studied. Now we are going to learn the chemical properties of carbon compounds. In our day-to-day life, we are using so many fuels, right? These fuels are nothing but either they are carbon or carbon compounds they are. Carbon in its all allotropic forms, when it undergoes combustion, it produces carbon dioxide and liberates heat and light. If you write that under combustion, if it is carbon, when it is undergoing combustion, it forms carbon dioxide plus heat and light. Heat and light is coming. Next, here, if methane is burnt, methane gas, when it is undergoing combustion, it produces carbon dioxide plus water and heat and light. Heat and light. It is producing. Now, if it is alcohol, when it undergoes combustion, It produces carbon dioxide plus water and heat and light. Heat and light. Right? Now, if you balance the chemical equations, just here hydrogen here 2, it is here 4. If you write 2 here, oxygen 2, 2, 4 oxygen, here 4 oxygen. Hydrogen is balanced, oxygen is also balanced, carbon is also balanced, it is balanced. Here also skeletal equation it is written. You can balance just by checking the number of atoms on both the sides. If it is carbon dioxide, let us balance the hydrogen here. If you balance the hydrogen, here 3, 2, 5, 6. Here if you write 3, 3 2s are 6, and oxygen is 3 here. Now let us try to balance carbon. Next, here 2, here 1. So let us write this one. 2 2s are 4 oxygen plus 3 oxygen 7. Here 1 plus 3. So if you write here before this oxygen, if you write 3, 3 2s are 6 plus 1, 7 oxygen. So it is balanced now, the chemical equation. This is the process of combustion. Means we can say that carbon compounds, when they are undergoing combustion, they form carbon dioxide and liberate heat and light. Okay. Sometimes water will also be produced in compounds of carbon. Now coming to combustion, saturated hydrocarbons, when they are undergoing combustion, they give clean blue flame. Means they are completely burning. They are undergoing complete combustion. Whereas unsaturated hydrocarbons, when they are burnt, they produce lot of black smoke and they are giving sooty flame. We call it as sooty flame. If the flame is coming, yellow color flame along with the smoke if it is coming, that is sooty flame. They are giving unsaturated hydrocarbons. But in some special cases, even these saturated hydrocarbons, they too do not undergo complete combustion if there is limited supply of air. If there is sufficient supply of air, only then that saturated hydrocarbons, they give clean flame and they burn completely. They undergo complete combustion, right? Unsaturated hydrocarbons, they do not give that. Just they are producing a lot of smoke. Because of that, the bottoms of the vessels, when we observe, they will be blackened. Means what? If air holes, if they are blocked, then that whatever the fuel it is coming there, it is not undergoing complete combustion. Means there will be wastage of fuels, we can say. So this is just about a combustion of carbon compounds. Now let us try to understand what is oxidation here then. Then what happens when these carbon compounds undergo oxidation? Uh, Here carbon compounds, when they are reacting with oxygen, they undergo complete combustion, of course. But in some cases, in some reactions, these carbon compounds, they produce carboxylic acids when they are oxidized. For example, here combustion of ethanol, if you take CH2OH, when this is oxidized in presence of alkaline KMNO4, alkaline KMNO4, or acidified or acidified K2Cr2O7, that is potassium dichromate, acidified potassium dichromate. These are getting oxidized. This alcohol, it is getting oxidized to carboxylic acid, that is CH3COOH, it is forming. Means it is getting oxidized toward carboxylic acids, right? This is some special cases, and here we can say this is the substance. Alkaline KMNO4, it may be acidified potassium dichromate, it may be. These are helping that alcohol to get oxidized. Means it is oxidizing the alcohol. So what happens here? This substance is called what? Oxidizing agent. Alkaline KMnO4 it may be, or acidified potassium dichromate it may be. They are called oxidizing agents because they are helping that alcohol to get oxidized to carboxylic acid, right? These are oxidizing agents we can say. Next, coming to addition reaction. What is addition reaction then? Some of the unsaturated hydrocarbons, they add hydrogen, okay, and they convert to saturated hydrocarbons by adding hydrogen. Then that type of reaction, that is called what? We can say addition reaction. For example, here this is unsaturated hydrocarbon, we can say. This is any functional group. Now when this undergoing addition reaction, there must be one agent again. What is that agent? Either nickel or palladium catalyst. If any one of these catalysts, if it is present, it adds hydrogen to these unsaturated hydrocarbons. For example, if it is nickel catalyst, here it is adding hydrogen to this. So what this changes to then? This changes to saturated hydrocarbon. This is R, this also R. Here 2 hydrogen, it is adding to that. Now this addition reaction can be seen in hydrogenation of oils, that is vegetable oils we can say. Vegetable oils are, they are unsaturated hydrocarbons. When they are subjected to hydrogenation in presence of nickel catalyst, that hydrogenation of oils, that is vegetable oils, takes place. So these we say here vegetable oils, they are healthy ones we say. Animal fats, they are harmful we say. Means unsaturated fatty acids, they are good for health, that is present in vegetable oil. And unsaturated, this is saturated fatty acid which is present in that animal fat, that is not good for our health, as it is recommended by the doctors or in some advertisements we might have seen, right? This is just about addition reaction. Now let us try to understand what is substitution reaction then. Most of these saturated hydrocarbons, they are unreactive and they do not react with any other any other elements or compounds it may be. They remain unreactive, but in presence of sunlight, these saturated hydrocarbons, their chlorine replaces hydrogen one by one in presence of sunlight. For example, if we take in substitution reaction, this is addition reaction. This is all related to combustion upon. This is addition reaction. Next, coming to substitution reaction. In substitution reaction, what happens? Here if you take methane, here chlorine, it reacts with chlorine in presence of sunlight. Very fast reaction takes place. Here CH4 it is methane, okay. Chlorine, it is replacing the hydrogen, so this becomes here CH H, that is one chlorine it is adding, and along with that one hydrogen from this methane and one chlorine from this chlorine gas, it is converted to hydrogen chloride HCl. HCl in the form of HCl hydrogen gas, hydrogen chloride gas, it is liberated there. So this is what CH3Cl, chloromethane we can say this one. Means fully have written this one structural formula. It is not required. Just we can say this is chloromethane. Just CH3Cl we can write. So this is the reaction of substitution. Why we are calling this as substitution reaction? Because one atom is replacing the other. Means chlorine is replacing the hydrogen there. So that is why it is substituting that place of hydrogen. So because of that we can say this is substitution reaction, right? Next, let us come to know about the commercially important carbon compounds, that is ethanol, properties of ethanol, and reactions of ethanol that we need to study. Now let us study the properties of ethanol. Ethanol, it is a good solvent and it is an active ingredient of all alcoholic drinks. And this ethanol, since it is a good solvent, it can be used to prepare cough syrup, tonics, and in some medicines also they are using, and tincture iodine. They also it can use this one. What ethanol can be used there to prepare them. Now coming to ethanol, what are the reactions? Means this ethanol, for some people it causes drunkenness if they are consuming it in small quantities regularly, and it may cause lethal effects also in a prolonged consumption. And this reaction of this ethanol with some other substances, when we consider, first one is sodium. When ethanol reacts with the sodium plus ethanol, CH3CH2OH, when you take this, it is giving one compound called sodium ethoxide, ONA, and along with the evolution of hydrogen gas H2, it is coming up. This is just reaction of ethanol with the sodium. Okay, it is giving one compound called sodium ethoxide. We call this as sodium ethoxide, and this hydrogen gas is liberated, right? This is one reaction, first one. This is a reaction with the sodium. With the sodium we can say. Next, second reaction is this ethanol. It produces unsaturated hydrocarbons when it is reacted with excess concentrated sulfuric acid at 443 Kelvin. When we heat this ethanol, that is ethanol, when it is heated at a 443 Kelvin, at a 443 Kelvin, when it is heated in presence of excess concentrated sulfuric acid, H2SO4, that is concentrated sulfuric acid, H2SO4. This gives it gives ethene, that is we can write this as CH2 double bond CH2, and water is also liberated. Now this is nothing but ethene. If you write this like this structural formula, you will get like this. It is forming unsaturated hydrocarbon. When ethanol reacts in presence of, when it is heated at 443 Kelvin in presence of excess concentrated sulfuric acid, it changes to unsaturated hydrocarbon, and it is undergoing dehydration. Dehydration means removal of water. What is removing the water? This sulfuric acid is removing the water from this ethanol. So we can consider this concentrated sulfuric acid as dehydrating agent. We can call it as dehydrating agent because it is removing the water from the ethanol there, right? So this is the reaction of ethanol. When it is heated at 443 Kelvin, what happens? How it is changing to unsaturated hydrocarbon, as well as when it is reacting with sodium, that is sodium ethoxide, that compound is formed along with evolution of hydrogen gas, we can say. This is reaction of just ethanol. Then we need to learn about ethanoic acid. First, let us try to understand what are the properties of ethanoic acid. Ethanoic acid is commonly called acetic acid, and this is a commercially important compound, this also. And this acetic acid, when it is 5 to 8% solution in water, 5 to 8% solution in water, when it is prepared, this is called what? Vinegar. We call this as vinegar. This is only vinegar. Now, this acetic acid, its melting point is just 290 Kelvin. Just 273 Kelvin means it is 0 degree Celsius, as you know already. At 290 Kelvin, its melting point is there. So, during winter season, in cold climatic conditions, it just solidifies. Means it becomes what? It freezes. So, because of that, the name is given to that acetic acid as glacial acetic acid. For this ethanoic acid, we can also call it as glacial acetic acid. That is the reason it has got the name, right? Now we need to learn what are the reactions of this ethanoic acid with different things. First, ethanoic acid, we are learning one reaction, that is what? Esterification reaction. Now, reactions of ethanoic acid. Okay. Before learning that reactions of ethanoic acid, these vinegars, where it is used, we need to know that also. Vinegar is used as preservative in pickles. Okay, and this vinegar is, as it is acidic in nature. Group of these carboxylic acids, they are acidic in nature. Okay, and but still they are weak acids. Why they are weak acids? Because they do not get completely ionized, just like mineral acids like HCl. HCl, it gets completely ionized as H plus and Cl minus, whereas carboxylic acids, that is acetic acid, if you take, it does not get completely ionized. So because of that, we consider it as weak acid. Okay, right. Next, coming to that reaction of ethanoic acid, that is esterification reaction, we say. Here, uh, this ethanoic acid, it reacts with ethanol to give esters. Here, ethanoic acid, CH3COOH, ethanoic acid, it reacts with CH2OH to give esters. Esters is CH3COO, CH2, CH3, and plus water. It is liberating water. So it is getting converted to what? Ester. What are esters? Esters are sweet smelling substances. They are used in the preparation of perfumes. These esters, again, they, when this ester, when it is treated back with alkali, that is sodium hydroxide, this ester, it is converted back to alcohol and sodium salt of carboxylic acid. Okay. See how, for example, uh, ester CH3 COO COO CH2 CH3, when it is treated with NaOH, that is alkali sodium hydroxide, it gives back, so ethanol, it gives CH3 COO CH2OH plus it is giving sodium salt of carboxylic acid, that is CH3COONA. It is giving this reaction. We call this it is called saponification. Okay, this reaction of saponification, it is used in the preparation of soaps, to prepare the soaps. That is why that it has got the name as saponification reaction. Then what are soaps then? Soaps are nothing but they are long chains of carboxylic acids containing salts of either sodium or potassium. Means what we can say, they are either sodium or potassium salts of long carboxylic acids chains. They are acid chains. Okay, so that is why we can say these are used in the preparation of soaps. That is saponification reaction, we can say. Now let us study how does ethanoic acid react with a base, that is sodium hydroxide. If you take this reaction NaOH, sodium hydroxide, plus ethanoic acid, these react to give sodium salt of, that is sodium acetate, CH3COONA, that is sodium salt of carboxylic acid, plus it is giving water. This hydrogen it is replaced by, that is by Na and OH and H, it is giving water. Then what are the reactions of this ethanoic acid with the sodium carbonate and sodium hydrogen carbonate? If you take that, here so with the sodium carbonate and the sodium hydrogen carbonate, if you want to consider, that is ethanoic acid CH3COONA, COOH, ethanoic acid plus sodium carbonate Na2CO3, it is giving the product sodium salt of carboxylic acid, that is sodium acetate it gives first, that is CH3COONA it gives, plus it is giving carbon dioxide and water, that is water and carbon dioxide. And what about the reaction of this ethanoic acid CH3COOH with sodium hydrogen carbonate NaHCO3? What happens when it reacts with this? It is also giving same products, that is CH3COONA plus water and carbon dioxide. Here you don't need to get confused at all. If it is asked, it may be sodium carbonate or with a sodium bicarbonate, the products obtained will be same, that is sodium salt of carboxylic acid, that is sodium acetate we are getting, water and carbon dioxide. The same products we are getting in both the cases when that ethanoic acid is reacting with either sodium carbonate or sodium bicarbonate, that is sodium hydrogen carbonate, we can say. So these are what just a reaction of a ethanoic acid with the different substances, we can say here, compounds what we have taken so far. Now we will go ahead with soaps and detergents. What are soaps and what are detergents? That we need to learn, right? Soaps are nothing but they are long chains of carboxylic acids containing either sodium or potassium. So what we can say, they are sodium or potassium salts of long carboxylic acids chains, we can say acid chains. Okay. Here soaps, when they are treated with water, what happens, that we are going to learn. Now let us study what are soaps and what are detergents. Soaps are their sodium or potassium salts of long carboxylic acid chains there. Okay. Now here, actually when we are washing the clothes, otherwise when we are saying we are removing the dirt by washing. Dirt is most of the dirt that is oily in nature. Okay. Here, this oil does not dissolve in water. Oil will not get dissolved in water. But here, when we take this long chain of carbonic acids, that is either sodium salt or potassium salt, when we are taking, it is having two ends. This is one end. This is long chain of carbonic acid, and this is what ionic end we can say. If it is Na plus, here carboxylic end it is. This is facing towards the dirt, that is oil drop we can say. This is oil drop. It is facing towards that. This is facing towards water. We can say this is hydrophilic end. This one is hydrophilic end. This is hydrophobic end. This is just moving towards the oil. It is attracting the oil. This is attracting the water. So what happens in water? These form a structure called a micelle. They form a structure called a micelle. This is oil drop. Okay. These ionic ends, it is pulling towards the water, and this forms an emulsion in water. Means it does not get precipitated, just it becomes an emulsion and it remains in the water. When we wash it, putting more water, it will be just cleansed very easily. Okay. This is how the soaps are working. Very simple. It is just long chains of carbonic acids containing sodium or potassium ionic ions we can say. Here these ionic ions, they are moving towards the water, they are attracted towards the water, and the carboxylic end is that is attracted towards the oil drop. These just floating in the water, they will pull that drop, that is dirt, from the whatever the surface what we are cleaning there, this cloth whatever it is. Now coming to here, sometimes when we are having bath, that time we may find little difficult to uh, form the foam there. Foam will not be formed. With great difficulty it will be formed, and dirt will not be cleaning easily. What is the reason there? These sodium salts, ionic end would be there, that is either sodium or potassium, that is reacting with calcium and magnesium which is present in the water. These calcium and magnesium salts, they cause hardness of the water. If it is hard water, in that calcium and magnesium that will be in more quantity. When we are using this type of soap there, it is just forming just uh, an insoluble precipitate is formed there. This ionic end, when it reacts with that magnesium or calcium end of that salt in the present in that hard water, it forms an insoluble precipitate. When it forms an insoluble precipitate, it cannot clean the dirt from the cloths. Okay? So in that case, we are using another class of compounds, that is detergents we say. Detergents, they are also what? Long chains of, they are also either sulfonic acids or ammonium salts. These are present in that in the long chain of carbonic acids. Okay. These do not form what we can say here insoluble precipitate when it is even if the water is hard there. So in that case we are using detergents. These in detergents, what is happening, that sulfonic end or that ammonium salt, that end, they do not react with what, either calcium or magnesium of that hard water there. They do not form insoluble precipitate. As a result, dirt can be cleaned easily there. So that is why detergents are more better than that soaps when we are using hard water. Next, coming to your soaps and detergents. If you take detergents, they are used in preparing shampoos or products of uh, washing the clothes, whatever the products. If they are for example liquids for washing machines, it may be soap. Some detergent powders, it may be detergent cakes, it may be there. They are using these substances, that is what we say detergents. Okay. So this is all about carbon and its compounds. uh, if you have any difficulty, you can comment the topic. I'll make the video on that, and just you can go through and you can get ready for your examination. Okay, hoping you will do better in the exam. We are just I'm going to finish this video. Complete lesson you can observe in the single video. It was of course difficult for me to conduct, as we have been engaging that physical classes. It is difficult to make the videos after 12 o'clock. I am making this, so little difficult at this time. Of course it is finished. uh, so if you have any difficulty, you can comment the topic. I'll take up whatever it may be. uh, if it is biology, chemistry, physics, maths, whatever it is. So I can go ahead with next video. Let us meet in this next video. Okay, thank you.